Hi guys, this is the South County Math Tutor, and I want to thank you again for following me on this Flat College Algebra video series. We are now at 1.6 logarithms, so let's go ahead and get started. All right. First things first, you're asking yourself, what's a log? What are logarithms? Okay. Before we talk about logarithms, let's talk about their opposites. The opposite of logarithms, which is an exponential function. Okay. So for example, if you had something like 2 to the x, notice how the variable is actually an exponent that is considered an exponential function. So this is a function when something is doubling. So for example, if x equals 1, 2 to the first power is 2. So first power is 2. Okay, if x equals 2 to the second power is 4. When x equals 3, it's always doubling. So 2 cubed is 8. 2 to the fourth power is 16. Okay, so if you're thinking about something that's doubling, something that's tripling, something that continues to cut in half, okay, for example, you have a certain bacteria and you take medicine and it talks about half-life. These are exponential functions. Okay, and the graph of an exponential function looks something like this. Okay, so it's increasing for a function like this is increasing quickly. Okay, so it's increasing quickly like that. That's an example of an exponential function. Okay, so logarithms are the opposite. They're the inverse, just like addition is the opposite of subtraction. Multiplication is the opposite of division. Log functions are the opposite of exponential functions. Okay, so for example, you might have something like this, whereas the logs always have bases. So log base 2 of 8. What this is asking you is 2 to the what power will give you 8. What do you have to raise 2 to get 8? Well, 2 to the third power, like we saw right here, 2 to the third power is 8. So log base 2 of 8 is 3. Okay, or let's say something like log 2 of 1/2. Okay, 2 to the what power will give you 1/2. Well, if you remember that to get a fraction, you need to have a negative exponent. So 2 to the negative 1 is 1/2. So the answer to this is 1. So logs are just, they sound weird, but they are just the opposites, the inverse, what undoes exponents. Okay, so let's do another one. How about log base 4 of 4? Okay, that turns out to be an identity. 4 to the what power gives you 4? Well, 4 to the first power gives you 4. Okay, so again, what are logarithms? Logarithms undo exponents. So that is what this means. Logarithms are the inverses or the opposite of exponents. Okay, so we need to be able to do, today we're just going to stick with logarithms, what they are, converting logarithms to exponents, and properties that help you condense and expand exponent, logarithms. So that's what we're going to do. So right now, let's go ahead and stick with the first things. How do you convert an exponent to a log? Okay, log short for logarithms. Okay, so how can we convert exponents to log? Okay, here's an example. Let's learn this by example. Okay, let's say you have exponents. We want to convert exponents to log. Okay, so let's say we know that 9 squared equals 81. Okay, now let's convert this to log. Let's write the exact same thing, but this time introducing logs. Okay, it turns out that you can write it as log base. The same base that you have for an exponent will be the same base for the log base 9, and then you it's like writing it backwards. So log base 9 of 81 equals 2. Okay, so log base 9 of 81, what exponent do you need for 9 to give you 81? Well, 9 squared is 81. So I like to teach my students to do the circle of life. Okay, so this is what I mean by the circle of life. Okay, so circle of life, you start with your base here and then here. Notice, make a complete circle. Log base 9 of 81 equals 2. Okay, so let's do another one. A to the m equals b. Okay, let's do the circle of life. Circle of life, your base of this equal that. Okay, so based on our circle of life, log base a of b equal m. Okay, so you can switch back and forth. Those two things are saying the same thing. One is using the idea of exponents, and the other one is using the idea of log. Okay, what if we want to go backwards? How do you convert? You want to convert from log to exponents. Okay, let's convert from log to exponents. Okay, so let's say you have a true statement, log base 2 of 16 is equal to 4. And now we want to convert it to exponents. Start with your base, always start with your base. Well, 2 to the 4th power equals 16. Again, we can do circle of life. Okay, circle of life. 2 to the 4th power equals 16. So you can kind of use that idea, okay? Use the idea of a circle of life to be able to convert. And it makes this a really easy question. Okay, so what if you have log base 3 of 1/9 equals -2. Okay, again, circle of life. 3 to the -2 equals 1/9. 3 to the -2, 3 to the -2 equals 1/9. Okay, and remember when we looked over exponents, the negative just changes the position. So the negative, if you were trying to solve this problem, the negative will make this 1/3 squared, and 3 squared is 9, which is 1/9. Okay, so that is a true statement. Log base 3 of 1/9 is actually 1/2. Okay, now we move on to the next thing. The next thing is looking at log properties. Okay, so let's find my log property. I already have it here. Let me erase some of these things. Okay, so it turns out that the log properties are similar to exponential properties, which makes sense. Okay, let's go ahead and practice some of these problems. We are going to read the problem, rewrite each equation in exponential form. Okay, so you should expect it to be in log form, and it's asking you to rewrite it in exponential form. Whenever you see that, circle of life. So think to yourself, we're going to do circle of life. 32 to the 1/5 equals 2. Okay, so this is 32 to the 1/5 equals 2. And you're done. Okay? Circle of life. 20 squared equals 400. 20 squared equals 400. If you're going from log to exponent, you drop the log. Base squared equals 400. Circle of life. Okay, rewrite into logarithm form. So you know your answer is going to have log on it. So log, circle of life, log base 15 of y equals x. Log base 15 of y equals x, circle of life. Log base 15 of y equals x. Okay, m to the n equals 130. Again, you're changing to log, so you introduce the log, base m of 130 equal n, circle of life, log of m of 1/3, log m of 130 equals n. Okay, so our next problem is asking you to expand. So we're going to take this and we're going to expand it. All right, so I'm kind of bored of this color. I'm going to change it a little. Use this. Okay, so we are going to expand. Okay, if you look at the properties, which you're going to have to remember, you have to learn it, memorize it, do a lot of examples so that you know it. Multiplication becomes addition when you split it up. So log, remember, if it doesn't have a base, the assumption is that it is base 10. So log base 10, log x plus log y is your answer. Again, if you don't have a base, you know it's a base 10. Okay, division becomes subtraction. So this is log of x minus log of y. Again, we are expanding. Expand means that you're going to have for each variable, you're going to, well, I don't want to say that, but you are going to split it into more than one log. Okay, so we haven't really looked at cube root function. So I'm just going to tell you. This cube root of x is the same thing as saying x to the 1/3. So with logs, you're going to have to change things into exponential function like this. So if you have a root function, you want to change it into an exponent. And then remember, when you are expanding, exponents become coefficients. Okay, so this now becomes 1/3 log of x. Okay, again, you have log a to the 6. Exponents become coefficients, so this is 6 log a. Okay, log base 4 of u to the 4th and v squared. You're going to have to do it one step at a time. Well, to start off, I see that this is division, and you should know division becomes subtraction, so that's the first thing I'm going to do. So this is log base 4 of u to the 4th, and this is a u, minus log base 4 of v squared. It's not completely done yet because we still have this exponent, okay? And exponents, when we expand, becomes coefficient. So we're doing it one at a time. So this will be 4 log 4 of u minus 2 log 4 of v. Okay, and here, again, one step at a time. If you see multiplication, let's go ahead and do that first. So this is multiplication becomes addition. So this is log x plus log y plus log z to the 6th. Okay, this is already expanded, this is expanded, but this is not completely expanded. That becomes 6 log z. Okay, and then just copy everything else down because they're all expanded. Okay, that's your final answer for that one. Okay, now these questions are asking you to condense. Okay, so we want to condense them. So when you're condensing, just go look through the question. Notice how this is all coefficient. So we bring it into an exponent. So this is log 6 of x squared minus log 6 of z squared minus log 6y to the 6th power. Okay, so it still has 3 separate logs. To condense it, your goal is to make sure all of it comes together into one log. Now, it's all being subtracted, so you want to do log 6. Subtraction becomes division. So this is x squared divided by z squared and divided again by y to the 6th. So it's log 6x squared over z squared y to the 6th. Okay? Next, number 12. And notice we now have one log. This is log base 6, x squared. You can put that in parentheses to keep them together if you'd like. Log x squared over z squared y sixth. Number 12. You see this and then you see all the additions, okay? Additions, it becomes multiplication. And notice how you see all these thirds below that. That's like saying I'm going to rewrite this as log. Okay, let's make this a little bigger. Log base 5 of w plus, if this is a denominator, it's like saying 1/3, right? Divided by 3 is like cutting it in 1/3, in thirds. Okay, log 5 of x plus 1/3 log 5 of y plus 1/3 log 5 of z. Notice how all of these are on all 1/3, okay? So these coefficients become exponents. So this is log 5 1/3, 5x to the 1/3 plus log 5y to the 1/3 plus log 5z to the 1/3. Okay, and I'm gonna just bring an arrow down for this one because that's not to the 1/3. Okay, all of them are to the 1/3 and they're all added to each other. Addition becomes multiplication. So I'm gonna say log 5 x y z, and since all of them are to the 1/3, I can do this, right? Because if you distribute it, it's like x to the 1/3, y to the 1/3, z to the 1/3. Okay, so that's that. And then plus log 5, okay, plus log 5 of w. Again, it's being added. We want to make them 1, okay? So to condense it, you want your answer to just, as much as you can, you want your answer to be just 1 log, as long as they all have the same base. Okay, so this is log 5 of w times this chunk. Okay, it's by itself because it's not being raised to the 1/3 like all the other ones. It did not have the coefficient of 1/3. And then once you learn this, you could also write this as log 5w cubed root times the cube root of x, y, and z. Okay? So that is our practice of logs. I hope this made sense to you. Please go ahead and work the problems, and if you have any questions, shoot me an email. Thank you. Okay.